All right, so the chain rule. What rules do we know?
Product and quotient.
Product rule, quotient rule, power rule, right? We're halfway through. We need to know the chain rule, how to calculate an inverse derivative, and something called implicit differentiation. So we have 3 to go. What do you know about chains?
They're linked together.
Yeah, they're linked together, right? Okay, we're going to use this. It's why we call it the chain rule. This is a similar idea of calculating a derivative. Okay, we use the chain rule for composite functions. Do you remember what that is?
Absolutely not. We didn't do it in the last week.
If that's all you can remember, your life's going to be very difficult. All right. You know how to calculate that derivative? Yeah?
Yep.
Okay. Do you know how to calculate that derivative?
Yeah.
Yeah.
Okay. Can you calculate this derivative?
Nope.
Why you using the chain rule?
Yeah, pretty much. Thanks for that. You guys are using contextual clues very well today.
I'm a mind.
Can you calculate that derivative?
Yeah, using that.
Eventually, not today.
You'll be able to by the end of the day.
Oh, that
Right?
makes sense. No, it
So,
doesn't. Because it
The chain rule is just a combination of this rule here and this rule here. Okay? So we're chaining those together, right? So what is the derivative of f? Okay? And the derivative of g? Okay, the question would be, what is the derivative of f of g of x? Okay. We start with this one. We use the power rule, okay? So we have to do the power rule first. Okay. So in the chain rule, we would call this the outside function. And we would derive the outside function. It's one way to think about it. So what's the power rule here? Bring the 2 down, subtract 1, right? Do you change the middle? If this x, did you change it here?
No.
No, you didn't. So we just leave the middle the same. Okay. So derivative outside, then we copy the inside, right? Whatever's there. Copy the inside. Okay. Now, since this is a separate function itself, we also have to consider the derivative of it. And you're done.
is that a format thing where you put the prime at the end of the f of g of x instead of the thing at
Yeah, if I put f prime of g of x, that would mean put g of x in f prime.
the? Oh,
This is f g of x prime.
so is it?
Yeah. So basically we are deriving the whole composite. All right, so again, derived the f of x portion, the outside, right? Copied the inside, because it stays the same here. We don't change that. And then we also consider the derivative there, which is just 4 times 4. Okay. So this is derivative inside. Okay. So if you want a cute little jingle, somebody came up with one last year. The chain rule, one way to remember it, this is docidi. It's not an O, docidi. Okay. Derivative outside, copy inside, derivative inside. Right?
Wait.
Derivative outside, copy inside, derivative inside. Okay, let me color code that.
So that's your answer.
Derivative outside is the power rule.
Okay.
Okay, derivative inside or copy inside. And then derivative inside right there. Okay?
And then, so that's your answer for your
That's the
function,
derivative
right?
of the composed function.
Oh, okay, so you don't have to
Yeah.
go any farther.
You could combine 2 times 4,
Okay.
8.
Yeah,
And then this is only to the first power, so you could distribute.
right,
Sometimes you can FOIL.
okay.
I mean, algebraically, you can still work through some of these, but
Well, yeah, no, I was just wondering, like, for multiple choice, because I know.
for
like-
multiple choice, that's probably gonna be simplified.
Okay.
Yep, to be
Oh.
honest there. And we have learned that calculus is where we learn our algebra. Yeah? I did. I had to edit it. And it's still not done editing. Don't ask me, that's on that. It was almost 24 hours now. I trimmed it and still hasn't finished.
You used to leave it on,
I'm not gonna answer that question.
Yes, you did.
Okay,
So
next.
everything
All right, so
Throughout the day,
you
guys.
kind of have a general idea of the chain rule. It's just 2 functions together, chained together, right? How do you deal with that with derivatives? So I want to run you through a few of the different ones that you'll see, just to help your minds get settled on it. Okay. Let's try this function. Right. That is 2 functions composed together, correct?
Right.
Okay, what 2 functions are we using?
Sine x and x squared.
Right. Okay. Which one is the outside?
Sine
Yeah,
x.
sine x is the outside function. And this is the inside. Okay. So, what is h prime of x?
Cosine.
So, yeah, dou, right? Do, derivative outside, cosine. So, copy inside,
Squared 2x.
and derivative inside?
X squared, sorry. And then it's 2x, yeah.
Yes. And I can color code that again. Derivative outside, we'll go with red. Copy inside. And then derivative inside, we'll go with pink.
There you go.
Okay. Okay, it's a process. Okay, now it can get rather nasty,
I'd rather
but right now we're just keeping it simple, right? Okay. Anybody lost in the woods? The tree's gonna fall on your head.
No.
What's up?
So, I don't understand, like, how is it 2 different functions?
One function is sine x,
What is this?
So sine x is.
and the other is x squared. You have to compose those 2 functions. Right? So this function represents these 2 composed together. Right? Sine with x squared in it.
Alex, I don't understand. If we're composing this 2 functions, where is sine x?
You would put x squared in for,
So, if we were combining 2 functions, we would do that?
you're just putting this in
Oh,
there.
okay.
Okay. All right, let's try another one here. How about
No fun.
a root? Here's a root for you.
Oh.
You don't have to laugh mockingly, you could just not laugh. At least make me think I'm funny. How do I rewrite that as an exponent?
X to the 1 squared.
rewrite those. It's a square root, right?
Right.
1/2 power. Okay.
What is what's the exponent for x4?
X to the 4th plus 1 to the 1/2 power. Okay. Again, identifying outside and inside. Which one's outside?
X. Whoa. The 1/2 sounds like.
Yeah, this is our outside function. Our inside is here. No, it's the exponent 1/2. So when you derive the outside, what rule do we use for an exponent or power?
You subtract, or you bring it down and subtract.
Yeah, it's the power rule, right?
But there's no variable with it, is there?
There you go, so x to the 4th plus 1.
Now copy the inside. The variable's in here.
It really turn into 1/2 to the negative 1/2?
Yeah, it does. You have your derivative, exponent derivative here. Bring this down, subtract 1. Now copy the inside. What's the derivative of the inside?
2x to the 4x.
4x cubed. That's the derivative.
Alright, I'm just confused on that negative 1/2 placement.
It's the exponent. You leave it in the exponent when you subtract 1. Oh, step over here. If I give you that function, derive
1/2 x to the negative 1/2.
yeah, exponent, coefficient.
That's what I was saying.
Exponent, coefficient.
Wait, the coefficient to 1/2 is not where you just said it.
Coefficient 1/2 is definitely in front of this right here.
Why?
This is your x value at this point.
Yeah,
You are just power ruling the outside of it.
but like, I don't understand the placement because if it was different, then the answer would be different once you like algebra it.
If you can.
Yeah.
No, the 1/2 has to come out front of everything.
Got that. But the negative 1/2 does not follow.
It does. An exponent, it stays an exponent. Just like here.
Alright.
Don't touch this. Everything's happening around it, outside of it.
So when you derive the inside, you put on the outside, you minus it?
It's a multiplication sign. No, that's not a minus, it's a line. No, multiply.
Also, we multiply it.
Yeah, that was just referencing over there. Yeah, times. Okay. Okay, let's try another one.
Oh, God.
Oh, stop it. Okay,
Would the E be the inside?
Ephraim, can you identify the outer function? Are you sure?
No.
I can tell you're not sure. You should be, because it's right. This is the outside. And the inside is cosine x. So, when you are identifying outside and inside, the question is, what function operation is done first? Okay. Here, the exponent has to be order of operations, right? PEMDAS, exponent first.
Parentheses first.
Yeah. It's already simplified, right? Okay. What about here? Which one has to be done first? The sign, right? The sign operates on this. That's why it's the outside. Here, the 1/2 rules the day. Okay. Here, the E rules the day. Okay. So what is the derivative of E? No.
Oh.
It's E, and then copy the inside. Right? Do that in green.
So it's the same thing.
You're forgetting the derivative of the inside.
So it's times
Okay.
Making those faces. You act like this is physically painful.
Well, every other inside we've dropped down, and it's easier to have it in the
But it's
exponent.
e to the x. You don't drop the x down when you do e to the x.
I know. But it's
Right?
weird.
E should be inside.
Derivative of e to the x is,
E.
right? So this is the derivative. Copy the inside. Well, our inside is just cosine this time. Okay? Okay?
So whenever we have an E in the exponent, the E and the exponent will always be derivative.
Times the derivative of the exponent. So you always copy this right here. This gets copied, then derive the inside. Yeah.
Thank you.
This is E, you copy the E, right? All right. Shall I subject you to one more?
Yes. Let me write this down.
All right.
Wait, where's the derived outside?
Do you want me to show you one where the chain rule and a quotient rule are combined?
Yeah.
Or just leave it for the day?
Leave it.
This is simple stuff.
Is it gonna be on our?
Well, I'll show it to you Tuesday. We're gonna keep working on this.
Oh, so.
Do you wanna
we're
save it
doing
for
Wednesday?
Tuesday?
Yes. Yes.
I guess you didn't have that information.
So is this like 3.7 E then?
Basically, um, so be aware that there are some problems here that are more difficult that I haven't given you any insight into. You gonna be all right back there?
Who said my name?
All right, so this is not due until Wednesday.
Oh, this is
Okay, but do please give these easier ones a shot, because if you can come and tell me, hey, I really can't do this on my own versus I can do this on my own, that tells me where I need to go. All right, so let me just give you a few suggestions. Well, it is one of the homework problems.
So,
Well, look, any of these
Bill or do?
do.
So we only have to do one?
Number one, you can do it if you want, but, if you could come, like, report to me that you can do those, it will tell me what I need to know about those. Okay? Yeah, 5, 11, 12, 29. Hunter, you just missed a layup.
yeah, I really did.
It's all right. I've been terrible too lately, to be honest with you.